second category is about the renovation projects. And I call on the stage now Klaus Rieker, Exco member from Germany. Please, Klaus, reach me here, and you can go ahead with the three finalists of your session. Thank you.
Yes, thank you, Andrea. I mean, I was amazed by what we saw so far this morning. I think we all as engineers, we like to build new things. And I think our society wouldn't be where we are today without the fantastic achievements, what we saw here. But equally, I mean, we have to maintain, we have to refurbish, and we have to reuse our projects. And so I'm very pleased to be presiding over the next category, which is renovation projects. We have three finalists here. The first finalist will be the Genoa Railway Junction Capacity Upgrade. And I would like to ask the team consisting of Luca Perozzoni, Alessandra Schiotti, Leonardo Di Gatti, and Giuseppe Erassi on the stage. I see. Thank you. And then the next project, what we have in this category, is the Manfreda Tunnel Renovation Project, also here in Genoa. And here the team is represented by Matteo Pascalotto and Lapo Bacciolini. Thank you for coming. And then we move away from the home turf and go to the Netherlands, and where we will hear about the refurbishment of the Heine Noord tunnel. And this will be presented by Irene Schnieders-Kleefmann and Bart Ranke. Please come on stage as well. Going into the second round. And all of you also brought presentations with you. So I think we just, without further ado, maybe the team from the Genoa Railway Junction could introduce yourself, and then we start with the video.
Sure. My name is Leonardo Di Gatti. I work for WeBuild, which is the general contractor of the project. And we are 4 people. Next to me is Mr. Giuseppe Irace, also from WeBuild, who is the project manager. And from Italfer is Luca Perazzoni and Alessandra Sciotti. Italfer here is the engineering firms working for the client. Me and Luca will make a short introduction of the project, if you allow. And then Alessandra and Giuseppe will participate to the roundtable.
Okay, perfect. No, thanks a lot, Leonardo. And then back to the team from the other Genoa project, from the Manfreda Tunnel.
Good morning. Thanks to ITA to be here. I'm Lau Baccolini. First of all, I am member of Italian Tunneling Association. I work as technical director of the Department of Tunnel Assessment in Tecne, the engineering company of Autostrade per l'Italia Group. Therefore, in Manfreda project, I represent the designer.
Thank you. Good morning, everybody. I'm Matteo Pasqualotto. I'm the project manager for Autostrade per l'Italia and also for this Manfreda Tunnel project.
Thank you. No, Irene.
Thank you, and thank you for inviting us. My name is Irene Schnieders. I'm project manager on behalf of the client Rijkswaterstaat.
Hello, my name is Bart Ranke. I am the technical manager for the contractor and responsible for the design and the execution of the renovation of the Heine Noord tunnel.
Okay, thanks a lot. So let's start with the Genoa Railway Junction project. I mean, Leonardo, you want to do a brief introduction and then we go to the video?
Sure, very short. This project is a project basically here in Genoa and is functional to the upgrading of the railway connection between the Terzo Valico project and the port terminals of Genoa, by means of important intervention on the existing urban network. It's a key project for the Ligurian network and also a strategic element within the current upgrading of the port of Genoa, which will be connected to the new lines in a more efficient way. Maybe Luca wants to say something about the stakeholders.
Thank you, Leonardo. I rapidly introduce the main stakeholder of the project, Rete Ferroviaria Italiana, the client of the work, Italfer, in charge of the preliminary design and work supervision, and WeBuild, in charge of detailed design and construction. There are also the institutional stakeholder, and in particular, Calogero Mauceri, the government commissioner, and Genoa region. And now I leave you to the video. Enjoy watching.
Oh, sorry. Push again? Huh? This is not working.
The Genoa Rail Junction project is the final mile of a major European work, the last segment of the Terzo Valico line, a 53-kilometer railway primarily aimed at improving the connections of the Ligurian port system with the main railway lines in northern Italy and with the rest of Europe. A key part of this project is the Genoa Railway Junction capacity upgrade, which will allow a separation of regional and metropolitan trains from long-haul services with a subsequent potential increase in the number of regional and metropolitan trains. To minimize the impact of underground works, many of the tunnels that will carry the trains are pre-existing structures undergoing repurposing, updating, and refurbishment. One example is the Grazie Bassa tunnel, built in the early 1900s to facilitate goods circulation from the old port and then decommissioned in 1939. Later on, in the 1980s, part of this tunnel was reused for the construction of Line 1 of the Genoa metro system. Within the Genoa Railway Junction project, a significant section of the Grazie Bassa tunnel has been reused for freight train traffic. The intervention has been part of the excavation of the new San Tommaso tunnel, a single-track tunnel which will be part of the upgrading of the connection between Genova Porta Principe station and Genova Brignoli. The new San Tommaso tunnel was designed to match the alignment of the initial section of the existing Grazie Bassa tunnel for about 850 meters. This choice improved the sustainability of the project, reducing construction impacts. To enlarge the cross-section of the old tunnel, a road header has been used in order to minimize effects in terms of vibrations on the existing structures in a highly urbanized area. Finally, the central section of the Grazie Bassa tunnel was renovated and transformed into an emergency exit for the San Tommaso tunnel towards Piazza Corvetto. Another significant renovation project is the widening of the Facchini tunnel, which is along the freight path from the Terzo Valico railway line to the port of Genoa. This 137-meter-long tunnel had to be widened to meet European standards for freight trains. To speed up the work and reduce rail line closure, a special protective metal shell was constructed at the north portal entrance, allowing train circulation to continue during the execution of ground treatment. This phase was completed using the horizontal directional drilling method over a 122-meter stretch, where a series of holes were drilled along the tunnel's upper section. A micro-cement mixture was then injected, forming a protective arch over the existing tunnel. The use of the HDD technique carried out was a new method in Italy for this particular purpose, allowing a significant portion of the consolidation activities to be concentrated in a single preliminary intervention before excavation, thereby achieving considerable time saving. Thus, railway traffic was only interrupted for the second phase of the work, consisting in the tunnel widening. In this phase, a new system was introduced, with the use of semi-automatic steel ribs. This system allowed the installation of the temporary support with the use of machinery and minimal personnel, thus strongly improving safety in the worksite. The tunnel excavation finished in about 3 months. Then the works continued with the installation of technological systems and the laying of the track over the new ballast, leading to the reactivation of the railway line in August 2023, according to schedule. Once the Genoa Railway Junction upgrading project will be in operation, it will have a significant sustainability benefit, meeting the EU target to transport 30% of goods currently moved by road by rail by 2030, reducing time, costs, and pollutant emissions in the atmosphere.
Yeah, thank you very much. Very, very impressive to have 3 types of work, refurbishment, reuse, and renovation in one project. So, I mean, that is excellent. Let's move with further ado now to the second project. Or do you also want to introduce it a little bit, or we should just go? Good. Good.
The Autostrada per l'Italia Group, a leader in the Italian motorway sector, manages a vast concession network spanning 3,000 kilometers, representing about 50% of the Italian motorway system. This extensive network covers 15 regions, with 4,200 bridges and viaducts, over 420 kilometers of tunnels, and 9,100 employees. The group has a diverse range of expertise, from engineering to construction, from sustainable technologies to innovative mobility services, allowing us to efficiently manage a complex network that is essential for the movement of people and goods within the country. In 2020, the Ministry of Infrastructure promoted a massive assessment on the service life's renovation of existing tunnels through different innovative relining solutions. The Manfreda project is the first to be completed out of more than 40 ongoing design applications. The southern carriageway of the Manfreda tunnel was constructed in 1977 and is situated on the A26 Vodri-Gravellona-Tocce motorway in the vicinity of Genoa. It was originally a monocentric twin tunnel with a winding trajectory, measuring 787 meters in length and 15.5 meters in width, allowing for 3 lanes in each direction. The tunnel was excavated through calc-schist metagabbroic rocks and serpentine schist. The maximum head above the tunnel is 138 meters. The rock mass on the Genoa side is highly fractured. The existing lining was thoroughly inspected and tested to assess its condition and identify the optimal treatment solution. The 90-centimeter thick original liner was deteriorated mainly due to the lack of a waterproofing system and to the poor construction technologies adopted at that time. The concrete casting technologies used at the time of construction unquestionably resulted in the creation of several hidden cavities in the tunnel lining. The design of the solution was based on the consolidation of the voids by means of nailing and grouting in order to safely proceed with the refurbishment and relining of the tunnel in the subsequent phases. Milling and hydro-milling were used as appropriate, depending on whether the original lining was reinforced or not. The polycentric milling shape was designed to minimize demolition at the crown and maximize it at the sidewalls. As you can see, this system provides the highest level of operational safety, ensuring the necessary clearance for vehicles in lateral lanes. The supporting beams were designed on both sides with anchors to provide a proper foundation and connection for the new reinforced lining. We have identified that the deterioration of the existing linings is primarily caused by circulating water. To address this, we have designed a robust waterproofing sheet and drainage pipes to collect and dispose of the water coming from the surrounding rock mass. The innovative waterproofing system is made of 3 pre-assembled layers and installed on the existing lining by Velcro strips. The cages were designed to be delivered on-site in 3 pre-assembled modules with proper bolted joints and few additional rebars to be installed, making this phase faster when compared with the traditional reinforcement. The decision was made to reline with high-performance sprayed concrete due to its unparalleled flexibility from both a geometrical and operational standpoint. The tunnel's unique shape made it clear that any other alternative relining solution, such as precast segments or cast-in-place concrete, would have been impractical. During the lining refurbishment of the Manfreda Tunnel's southern carriageway, an amazing machine was deployed in the opposite direction, the road zipper. It's around 3 meters wide and more than 30 meters long. As the name suggests, this machine, by physically moving a specially designed concrete barrier, can radically modify the layout of the highway in seconds. Based on the changing needs of peak traffic, the machine was zipping up and down the northern carriageway multiple times a day, reconfiguring the road without having to build a new lane. The road zipper is a big innovation, since you can mitigate congestion due to a tunnel closure with your existing opposite direction highway capacity. To change the layout, the road zipper uses a system of rubberized conveyor wheels. As the operator drives forward, it gently lifts and shifts the barrier diagonally across the underside of the machine. Crucial to the system is the barrier itself, made up of hundreds of interlocking 1-meter sections. 700-kilo T-shape elements are linked and articulated by metal pins, making the barrier an ultra-strong but flexible chain. By traveling at a speed of up to 8 kilometers per hour, the machine can zip a 2-kilometer barrier in just 15 minutes. As well as keeping traffic moving, it creates a safe divide between vehicles, which are traveling towards each other at dangerous speeds, something that humble traffic cones cannot do. 2 lanes were always guaranteed to the main flow direction, keeping both the drivers in the tunnel and the project's road workers safe. Finally, the road zipper enhanced time saving, cutting months from the schedule and allowing the reopening of the southern carriageway in advance.
Thank you. Thank you. Again, a lot of innovations as we saw in the first project, so it will be a tough competition, I guess. Let's move to the third project now, which is the refurbishment of the Heine Nord Tunnel, as I said before. And I think you have some slides you would talk to, and then we see the video. So Irene, please.
Yeah, thank you. Well, I'm very impressed about the 2 other projects. I hope we can impress you a little bit too. Yeah, I'd like to tell you a little bit about scope before we show the movie. It's a tunnel originally built in 1969, not only for cars, but also for, at that time, cyclists and pedestrians. And in this time, it's 50 years old, and it was really in need for a profound renovation. Please show the next. All the technical installations had to be replaced, but we had to do a lot of civil work as well. For example, building a new channel, because there wasn't a surface or channel to flee. Next, please. Yeah, and it's already a tunnel that exists. So we have a lot of people living around. And if the tunnel closes, the nearby routes for people are not really nearby. And a lot of traffic jam can be there. So everything we did, we had to find the right balance between execution, safety and accessibility. And of course the costs. Well, I think we did it pretty well. And I'm proud to present our video. Hopefully.
The Netherlands, a country famous for its efficient infrastructure, and particularly its hydraulic engineering. The secret to this reputation is innovation, organization, and cooperation. Nowhere is this clearer than in the Rotterdam region, with the Port of Rotterdam at its industrial center. This is where the sea meets the road and rivers that run into the hinterland. Underneath the Oude Maas River, near Rotterdam, is the Heinenoordtunnel on the A29 motorway, 13 meters below sea level. Since it opened in 1969, the Heinenoordtunnel has become an essential connection between the ports of Rotterdam and Antwerp, with more than 110,000 vehicles passing through it every day. It's also the main route to and from the Hoekse Waard, an island in the province of South Holland. To create a tunnel that is safer, more sustainable, and easier to maintain, we set out to complete as much of the renovation as possible with minimum tunnel closures. This is the story of the Heinenoordtunnel renovation. To set the scope for this project, Rijkswaterstaat partnered with the well-known infrastructure experts in the Severa 3 consortium, starting with the preservation of the immersed tunnel joints and concrete repairs. On the operational side, we planned a complete replacement of the technical installations, such as cables, lighting, and cameras, while creating a sustainable model to operate, manage, and monitor the tunnel in the future. Most impressive of all was the construction of a completely new tunnel feature, a central gallery with a separate escape and service gallery. Because of the economic importance of the tunnel, it had to be built quickly. Every tunnel closure leads to a financial loss amounting to 1 to 2 million euros a day. Our solution combined cutting-edge innovative construction with sustainable solutions and a gallery made entirely out of prefab parts. Hundreds of people built the 675-meter gallery in 7.5 days. Including preparation and installation, we were able to minimize the closure to just 4 weeks, while building a gallery the size of an apartment complex. By making the central gallery home to many of the technical systems, we could keep the tunnel open while installing new technical solutions, like laying 200 kilometers of cable to supply the tunnel with 100% Dutch green energy. The actual renovation of the Heinenoordtunnel took over a year and a half. Complete closures were minimized but sometimes unavoidable. To reduce travel delays and the associated financial damage, Closures were planned at weekends and during holiday periods wherever possible. We also took extra measures to keep the road accessible, like using the adjacent Tweede Heidenoordtunnel, originally intended for local farming traffic, for bus travel and emergency transport, and we made nearby ferries available for bikes and motorbikes. We combined these travel alternatives with a comprehensive effort to involve local companies and organizations aimed at promoting a willingness to reduce travel in the area. A video series with Rijkswaterstaat reporter Fiona explained the challenges, reasons, and solutions to the public. Along with active community engagement on social media, these efforts turned negative social sentiment into positive cooperation with local people and road users. The result? 12% less regional traffic, with a 45% reduction measured locally, which significantly eased the pressure on the underlying road network. Throughout the project, sustainability was key, from refurbishing old lighting installations that could be reused in other tunnels to using a local green energy supply. Even the new asphalt consists of 60% renewable materials. As you can see, we incorporated many different factors in the renovation of the Heidenoordtunnel, but we never compromised on safety. We created the safest possible work environment. The central gallery, where a lot of the work took place, was built to withstand the largest trucks that use the tunnel and was made completely fireproof. We also practiced the construction of the gallery with a custom-built mock-up to ensure that we met the tight schedule and safety standards. And technical specialists on both the client and contractor side were present in the tunnel every day, ensuring that the work was done safely. Every worker was also required to fill out their own safety reports. In the end, construction workers safely spent 756,000 hours working in the Heidenoordtunnel. The renovation of the Heidenoordtunnel produced cutting-edge solutions in an historically small time frame, with minimum closure times and using sustainable methods and an approach that will form the basis for at least 8 future tunnel renovations in the Netherlands. An historic renovation looking to the future and the start of a new chapter for this famous landmark of Dutch infrastructure.
Also, thanks to you, to a fascinating project and some innovations which we, I think, will discuss now in the next few minutes. I mean, ladies and gentlemen, we have now seen 3 excellent presentations on extending the use of tunnels constructed many years ago. Each of the projects had certainly its unique challenges, which were overcome by bespoke, innovative solutions. Let's talk about those and other interesting features in the next few minutes. So let's start with the Genoa Railway Junction project. In your project, you had to widen, reuse, and rehabilitate various tunnels, and therefore different engineering solutions had to be used. What were the main challenges during design and construction for you?
Okay, thank you for the question. For the design stage, the main challenge was the environment, the context in which the 2 tunnels, the San Tommaso and Facchini, are located, and the constraints that come from this context. For the Facchini, for the San Tommaso tunnel, the key aspects of this context are the highly urbanized area with a minimal overburden, a limited job site spaces in the edit area, and mostly the network of existing railway tunnels, 6 tunnels, some dismissed and some still in operation, that intersect each other in a small area stretching for only 2 kilometers between the 2 main stations, Genova Principe and Genova Brignole. Speaking of the context, the geological and geotechnical context was, on the contrary, a favorable one, because the tunnel crosses good rock mass, Flisce di Monte Antola, characterized by an alternation of marls and calcareous layers. So the main concern in the design stage was for vibration induced by excavation, not settlements. For the Facchini tunnels, the context is completely different. We are not in an urbanized area, but we had a strict constraint related to the short time frame for the tunnel without rail service. And so this constraint was successfully managed by the constructor, and so I leave the floor to the constructor.
Good morning. Pleased to meet you. During construction, of course, is necessary to test design selection. The first test, HDD drillings were carried out during scheduled interruption of railway traffic, the more problem. Carried out specific inspection in the tunnel to check for possible problems. The overall good result during those preliminary phases allow to carry on with the operation with minimal risk on existing railway traffic.
No, thank you very much. Maybe just to follow on then on the Facchini tunnel, you used a steel structure to ensure train movement. Was this foreseen from the beginning, or was this an idea basically you came up during tendering or during construction?
On Facchini tunnel, we used the semi-automatic ribs. We tested this solution in other subside job subside in Terzo Valico project, and this use is very well for safety of workers in all condition of stable phase in tunnel.
Thank you very much. I mean, you answered basically more or less my follow-on question. I mean, my question actually was on the shell which you used outside of the tunnel. So was that foreseen from the beginning?
It was not in preliminary design, and it was introduced in the basic and final design from the contractor. The constraint was, as explained before, to contain the work in a very short amount of time. So it was an idea to save time and carry part of the operation with the traffic service, with railway going on. You have to consider that this existing railway is the one that connects Milan and Turin to Genoa, so it's a very busy one. So there was a solution to save the interruptive time scenario.
Okay, well done. Then if we look at the Grazie Bassa tunnel, reusing it, it shows that even a 100-year-old structure can successfully be extended in life. So what challenges did you encounter during the works necessary to enable its reuse? Any specific challenges during the Grazie Basso tunnel?
During design or during construction?
During construction, let's say.
No, during construction, we didn't encounter any major problem. I think the big thing here was the idea during the design phase of reusing some existing underground space, which is always a value. The idea of enlarging, widening the tunnel, of course, was a good choice. But during construction, we didn't encounter any major issues.
Okay. And I mean, now if we look at the three tunnels as a whole, I mean, you had a lot of innovations. What innovations would you think you would use on new projects, on other projects? I mean, which one do you think is the most successful for the future and could be used the best?
Before talking of a technical solution, I would say that the lesson learned is the use of an existing tunnel, in the sense that it's this approach that can be applied successfully in other projects. I mean, the Italian railway network has a length of about 16,800 kilometers, of which 1,600 are developed underground, with 1,000 tunnels built in the first decades of the last century. So this issue, the issue of maintenance, the issue of reusing whole tunnels is a big issue, not only for the Italian country, but also for many European countries. And this project demonstrated that behind the maintenance or behind the renovation, the upgrading and their use are two opportunities that can be taken into account in order to in order to meet the goal of sustainability, in the sense that there is much attention for the use of resources, for reducing the impact, for enhancing the territory and its heritage. And the sustainability indeed need technical solution, innovative technical solutions. So I give the floor to the constructor.
No, thank you very much. I think, that more or less summarizes, what we also do here as ITA family. Keeping tunnels which had been constructed 100 years ago alive, and even extend their life for the next, 50, 60 years, I think, which, like you touched upon, is very sustainable and has an advantage maybe over other structures. So thank you very much. Maybe a big round of applause to the team. And then let's move on to the other Genoa project, the Manfreda Tunnel. What was the most significant challenge you faced and which you overcame during construction or design and construction? Anything which comes to your mind?
Klaus, first of all, let me say that it's an honor for me and for Autostrade to be part of this contest among two impressive projects. It means that the upgrading, the reuse of existing tunnel is one of the most important needs of our engineering era, also in terms of sustainability. So it's really an honor to participate. Regarding the most significant challenge, the key to the success of the project, and at the same time the most significant challenge, was to be able to involve the contractor staff and all the other field technicians right from the design stage. The deep involvement of the contractor and our technicians was the key. Since in Italy, the use of shotcrete as a permanent lining is not a common solution, and in this context, it could be considered as an innovative solution. What was essential is to carry out preliminary field tests, and training sessions of the shotcrete applications, and in addition, to develop a detailed method statement for spread concrete. And finally, what was really important was the daily technical support provided by the design and shotcrete supplier teams during the progress of the works, which was able to refine the mix of the shotcrete, to collect the feedbacks, to fix issues, and to record what could be improved during the application, during the months, in order to improve day by day.
Okay, thanks. Now considering shotcrete, you said, and rightly, using shotcrete as a permanent lining is not so widely used. And I think I can also speak from Germany. We struggle to get permanent shotcrete into the works. So how did you manage to, is it according to the standards here in Italy now that you can use permanent?
First of all, ITA has provided a very detailed book regarding shotcrete as permanent lining, and the Italian Tunneling Association is ongoing a technical committee regarding single shell lining. So this is a very hot topic, and we can improve a lot in Italy, but basically, so far, in other countries, for in the north of Europe, permanent shot lining is the rule. So it's a topic to import these techniques also in Italy, and following a wide application, I think that we can achieve the standards of the other countries.
Thank you. Another innovation we saw was this road zipper, where you basically switch the traffic between the two directions, or increased lane from 1 to 2. Was that, I think you said in the video, one of the success factors? I mean, how much time did it actually save using that? And was it the first time you used such a machine?
Yeah, it was the first time we used that machine. I will say that as Autostrade per l'Italia, we are always seeking for methods to improve and reduce the exposure of workers to live traffic, and reduce the impact of our work zones on the users. Since we are acting in our sites on the actual highway that is open to traffic, so we always need methods to reduce our impact. So the road zipper, first of all, allowed us to reduce and enhance safety on site, because it allowed us to reduce the amount of hours that our workers were exposed to traffic during the installation and the maintenance of the work zone. Normally, this kind of work zones are made of flexible delineators, and they don't allow to have a physical barrier between traffic flows. Using the road zipper, we had a physical barrier between traffic flows, and it allowed us to extend the duration of our time frames during construction, because normally during holiday period, the summertime, Easter, Christmas, we have to stop and reopen, so shut down the construction site and let the traffic flows because of the high volumes that are coming and going from Genova. So the road zipper allow us to extend our windows, so work through Christmas, work through Easter periods. We had to stop during summertime, but it allowed us to reduce by almost 30% the time for that was prevented. Was planned at the beginning of the project, and at the same time, it reduced by almost 60% the exposure of workers on the road to live traffic. In fact, workers, to maintain and move this road zipper, were standing on the machine and working from there. So we didn't have any worker exposed to live traffic.
Oh, that's thank you very much. I mean, that's a really good innovation, and you would then probably also use it in similar instances in the future.
Yeah, we are currently using it in another project that is made of 8 kilometers of road zipper, made of 2 separate portions, 5 and 3 kilometers, always in A26. We are working at the same time on 5 tunnels, using the same technique of Manfreda, and we are able to manage traffic without major impact on the users.
Okay, thanks. So again, thanks, a big round of applause to the Manfreda team. Now let's leave home turf and go to the Netherlands, to the vicinity of Rotterdam, and to the Heine Noord tunnel. A lot of focus was certainly on the installation of the new central gallery. I mean, my question would be, how did you make space for the central gallery? Because I think you couldn't reduce the lane width. So how did you manage to do that?
Thank you for the question. Before the central gallery was built, there was a barrier where people, what the escape route was behind the barrier. And that barrier is removed. And on the place of the barrier, there were the concrete elements placed. And that's where was exactly enough space to make the central gallery. So we already had the space, but we used it in another way.
So it didn't impact on the lane width at all? Oh,
no.
Okay. No. Good. Then you described also in the video that you went for a prefabricated solution. And this was certainly, I guess, a key element of the installation and of the success of the project. Was this also foreseen from the beginning to use a precast solution, or did you have any other
that's
options?
a very interesting question.
Yeah.
The amount of closures was already foreseen at the beginning of the project. So we had, 31 weekends, 7 weeks. And in that time, we had to refurbish the whole tunnel, including building the central corridor, or the escape corridor. And the only possible reason or feasibility was by using prefab. Why is that? Because prefab is already hardened. We can place it, we can fix it to the existing walls. And after every closure, if it was a weekend or a long-term closure, we had to open for traffic. And it had to be safe for the tunnel, had to be safe for the traffic. Every time, every weekend, we should ensure safety. And that also is the width which there is for the passageway through the tunnel. Irene said there was space to build a corridor, but not enough space for additional works. And so we had to reduce. And prefab is a very quick way of building. So we actually had no other solution than this.
Okay, thanks. Like you described also, the Heine Nord Tunnel, it was in operation now for about 50 years. You mentioned that you had to do some concrete repairs and also preservation of the immersion joints. By the repairs which you carried out now in those two particular fields, by how many years do you extend the operation life now with the new measures?
That are actually two questions, but the first question is the main goal of this reservation was that we can have 30 years without big renovations. So everything we did for the civil part of the work was 30 years. But we also had to build all the technical systems to fit the Landelijke Tunnelstandaard, the National Tunnel Safety Code. And that is also, we want to gain it by 30 years, but the developments within the technical installations and also the lifespan of technical installation often is shorter due to innovations. But by building the service corridor on top of the escape corridor in the central gallery, we are able to do a lot of maintenance outside of traffic, reduce the amount of or to reduce the increase of the traffic that goes through, we are able to extend the lifespan. And so we hope for civil 30 years, no big renovations, and by the technical installations, many years to come.
Okay, thank you very much. I think just one final question. You said you also did a mock-up at the beginning to test the installation of the prefab. Was this helpful? I mean, would you do that again, or?
The mock-up is essential. We always use a sentence, expect the unexpected. If you start renovations, you do not always know what you can encounter. But also building a new technical systems next to the existing systems means a lot of reduction in space. When the tunnel was built and during previous renovations, all the logical places for installations were already taken. So we had to build it next to the existing installations. And that means bringing people into confined spaces. There's not a lot of room to work with, but we have to bring in the 200 kilometers of cables, all the installation cabinets, and that really is a problem. And by building a mock-up, you can show the people in execution, okay, this is what you can expect. Do you see things that may quicken the execution time? Or is there something wrong in the design? And it always makes people think. And the last, what I actually want to tell, there's a lot of similarity between our projects, and I realize now I really love tunneling. It's very, very nice business. But I would like a small moment of applause for all the people behind the people that are here. The success of the project are the people that are working outside, day in, day out, in the nights, in the weekends, go home. And we had 756,000 hours. Now that were not all our hours. That's the people outside. I would really like a big round of applause because they make our projects a success.
Yes, and make that. And I think that's already a thank you to your presentation. No, I have to say I was also amazed in the previous round table and in the presentations. I mean, a lot of emphasis was put on safety, and I think we're all here. I mean, first of all, to make the environment better, but also to ensure that our people can return safely home in the evening, and that the families have their family member back in a very good condition. I mean, with that comment, I think we are at the end of this roundtable. Again, I would like to thank all the participants for doing the presentations. I mean, were fantastic presentations. Thanks a lot for your engagement. I mean, like also Sanja said, it would be difficult for me to judge who should be the final winner. I mean, you're all winners already sitting here. So let's see what the outcome will be in the evening. And thank you once again.